Today we'll go through chapter 2, probability concepts and application. Let's start with question, what is probability? So you may say probability is a chance of occurrence of an event. Now this question of chance comes into picture because of certain uncertainty. For example, if we toss a coin, what will be the outcome? There is some amount of uncertainty. We know that it will be either head or tail, but we cannot be certain whether we will get head or a tail. Also note that in this example, getting head or tail are mutually exclusive. So which means that you either get head or a tail. You cannot get like both head or tail. If we consider a random variable x to be the outcome of this small experiment where we are tossing one coin, so this random variable which I am representing by x, let me write down, this is a random variable. So this is a random variable x. It is called random variable because it can vary randomly. We cannot say whether we will get exactly head or a tail. The value this random variable x can take is h or t, and associated with these two outcomes is the probability p, or chance of occurrence of head or tail. Obviously this is 0.5 and this is also 0.5. So both have 50-50 chances of occurring. So the total probability is 1. So this small table here, which shows how the probabilities are distributed for different values of the random variable x, which are heads or tails. So this table is called probability distribution table. Please note that to be a probability distribution table, such a table has to satisfy two conditions. If any of the two are violated, then that table cannot be called probability distribution table. P is in the range of 0 to 1. When P is 0, it means that that event is not going to occur. So for example, if a store has 10 TVs to sell, then the probability that they will sell 20 TVs is 0 because they don't have 20 TVs. Similarly, when P equals 1, it means that that event is sure to happen. If you take an example where we have, let's say, two dice. So because a dice has like 6 sides numbered from 1 to 6, you may get an outcome which is 1 and 1. Similarly, other possibility is the first dice shows 1 and the second shows 2. Or first one is 1, second one is 3, and so on. Or first one could be 2, second one could be 1. So each outcome has a probability of 1 over 36. And when you add, the total you get is 1. So if this is the situation, and let's say you want to find what is the probability that the sum of those two numbers equals exactly 4. So this is equal to probability that, let me put another type of bracket, so probability that your outcomes are either 1, 3, because if you add 1 and 3 you get 4. So 3 divided by 36, or 1 over 12. So that's the probability that the total at the top of two dice will be 4. So x varies from 0, then 1, 2, 3, 4, and 5. So x takes these values. And probability of x taking a value 0 is 10% or 0.10, such that the total is 1. Suppose this is known to us, then the question is like, how do we find the average? So another name for average is expected value. So expected value or the average are both are one and the same thing. Let's suppose that x represents a variable which is number of service calls. How to find the average, also how to find the variance, which is square of the standard deviation, and standard deviation, which is represented by S. So given a probability distribution like this, how do we find these average, variance and standard deviations? So we need to create a column by multiplying x and p. So x times p. So 0 times 0.1 is 0. 1 times 0.15 is 0.15 and so on. So you can do this calculation. So you get 0.6. You again get 0.6. 15 times 4 is also 0.6 and this is 0.5. So if you add, you get 2.45 service calls per day. And now we can calculate standard deviation, or first variance and then standard deviation. Now to do that, we create another column, x minus the average that we just now calculated, and then square times the probability value. So it means 0 minus 2.45 when x equals 0 times p. In this case p is 0.1. So if you do the calculation, you should get 0.60025. Similarly, the second value, so this is 0. Second value is going to be 0.31538. You would get 2.0475, which is your variance or S square. So S square equals 2.0475. And now if you take square root of this number, you'll get the standard deviation, which is 1.43. So standard deviation will be 1.43 service calls per day. So before we solve this problem given at the top, let me write down the formula for binomial distribution, which we also write like f of x. So this is ncx p to the power of x and 1 minus p to the power of n minus x. This is the binomial distribution formula using which we calculate the probabilities, where n is the sample size and p is called probability of success. So if I take some simple examples first before we solve the problem. Let's say in a situation n equals 20, sample size is 20 and probability of success is 0.7, then how do we calculate f of 12, which is what is the chance that random variable x will be exactly 12. And for this you can use either the formula above or an Excel function. So if you type this, let me first go to Excel and do that. Excel function, always you should start with the equal sign and then BINOM for binomial and then DIST for distribution, DIST. And as you start this bracket, you can see this function will ask you what is the number of success. So in this problem, the value of x, which is number of success, is 12, and then number of trials, which is the sample size, is 20, and probability of success we have is 0.7. Now the last value it is asking is for cumulative, and you should say false here. So once you enter, you get 0.114. So you get 0.114, and the values we entered was 12, and then N, and then P, and then false. Now the reason we put false for cumulative is because we are calculating a value exactly at 12. So when you have such situation where you are calculating probability of x equals something, we put cumulative as false. Now if you take this another example where n is still 20 and p is still 0.7, and let's say we are interested in finding probability of x less than equal to 15. Now we are doing a cumulative calculation because less than equal to 15 means x can be 0, it can be 1, 2, 3 up to 15. So to find this, you should use the same function. Now x, the value is 15 here, so I'll put 15. N is still 20, P is 0.7, and instead of false, now I would say true. So this will give you a value, and your probability will be 0.762. Now one thing to remember is that probability of x less than equal to 15. So this less than equal to is the format which is used in Excel. If you have a situation where you have greater than equal to, then you may have to do slight adjustment. So for example, if you have to find this probability where x is greater than or equal to 16, then what you must do is you should do 1 minus probability of x less than equal to, so because this is 16 here, you should do 1 less, it becomes 15. And now for probability of x less than equal to 15, you can use Excel function easily without any problem. So if you do this, you should get 0.238. So you have to first type in the proper function, and then that Excel function will give you this. So I'm going to write the function in this box here. Now for binomial distribution, expected value of x, which is the average or the mean, is always n times p. So in this example it is 20 times 0.7, which is 14. Similarly for binomial distribution, variance, which is s square, equals n times p times 1 minus p. So this is going to be like 14 times, and 1 minus p is 0.3, so 4.2. Now if you look at this example above, so it says 23% of automobiles are not covered by insurance based on data in 2006. So this 23% is the P. So P is 0.23. And then it says on a particular weekend, 35 automobiles are involved in traffic accidents. So N equals 35. What is the expected number of these automobiles that are not covered by insurance? Expected value is always N times P. So if you do that, you should get. Similarly, if you have to find the variance, so use the variance is N times P times 1 minus P. So you just plug in the values of N and P and you can get the variance. And for standard deviation, you take square root of the variance. The probability of x is given by f of x equals mu to the power of x and e to the power of minus mu divided by x factorial, where the random variable x can take values like 0, 1, 2 and so on. So this symbol here is mu, and generally it is the average or mean. The mean arrival rate is 10 passengers per minute. So that is the mu. Part A, compute the probability of no arrivals in 1 minute period. So what is the probability that x equals 0? Now to find this, I'm going to write Excel function in this box here. So equals Poisson, x is 0, and then you put value of mu, which is 10 passengers per minute. And because we are calculating value of x exactly at 0, so we would say cumulative is false. If you put this value, your answer should be 0.0000045. So probability is very small that there will be no arrivals in 1 minute period. Compute the probability that 3 or fewer passengers arrive in 1 minute period. So what is the probability of x less than or equal to 3? Note that whenever you have x less than or equal to something, so that time your cumulative value will be true instead of false. So same format for Excel function, but this becomes true. If you put these values, you should get about 0.01. Compute the probability of no arrivals in 15-second period. So remember, your mu is 10 passengers per 1 minute period. But if you want to convert to 15-second time interval as indicated here, so for 15 second you have to figure out what will be your mu value. So if in 1 minute you have 10 passengers, obviously in half a minute you will have half of 10, which is 5, and again in 15 second you will have half of 5, which is 2.5. So when solving Poisson distribution problems, one has to be careful. You have to look at what is the unit in which the question has been asked. So because now this is 15-second period, we should use 2.5 as a mu and not 10. So once you remember that, solving this problem becomes very straightforward. So what is the probability of x equals 0? So you would do the same thing, Poisson 0, and this is 2.5. And because again you are finding probability exactly at a value 0, whether it is 0 or any other number, as long as you have only equal to sign, you would always write false. It is not a cumulative calculation. So this should give you about 0.08. Part D is compute the probability of at least one arrival. So at least one means x is greater than or equal to 1. Now Excel uses less than or equal to format, so you have to first change this to 1 minus situation. So because this is 1 here, so when you write x less than or equal to, you have to go 1 down, so it becomes 0. So now you can enter this function in Excel. So as you know, normal distribution is a symmetric distribution. This is how it looks like. It has a bell-shaped curve, and for normal distribution, the two parameters are mean or average, both are same thing, and standard deviation. The average base salary for women salary is $67,000, that's the average, and for men it is less, which is 65,500. And the standard deviation is same for both men and women. A. What is the probability of women receiving salary in excess of 75,000? First of all, whenever we are solving this type of problem, we should make this type of picture. And let's say this is for women who has average salary of $67,000 and standard deviation is $7,000. Now we want to find probability of more than 75,000. So 75,000 is obviously to the right of 67,000. So somewhere here, and we are interested in area to the right. Now to find this area, we would use Excel function. And remember that both for discrete distribution that we covered, binomial and Poisson, it is also true for normal distribution that in Excel area is always given to the left. If you have to calculate area to the right, you have to do 1 minus. So to find this area, your Excel function will be equals 1 minus, and then you put the mean 67,000, and then the standard deviation 7,000, and for cumulative you should always put true. If you are doing normal distribution, you should always put true for cumulative, and this value for cumulative is always true, because probability at a single point for continuous distributions like normal is approximately 0. We always use cumulative. We always find area between 2 points, or area greater than some point or less than some point. So if you solve this or enter this in Excel, you should get a value about 0.127. The distribution is for men, where average is 65,500 and standard deviation is still 7,000. So far in ABC, given the value of point, like in terms of salary, we are trying to find the area under the curve. But in D, given the area, we have to find the point. So the question is, how much would a woman have to make to have a higher salary than 99% of her male counterparts? So basically the question is in terms of the distribution of male. When we make this normal distribution, we have to use average for men, which is 65,500. Standard deviation is same, $7,000. And because we are interested in 99%, so this area to the left is 0.99. And this question is basically asking, what is this value? What is this salary? To find this, we can use another function, equals NORM for normal. And because we have to do an inverse calculation, given the area, find the salary, so we can use NORM and then INV for inverse. Probability value is 0.99, average is 65,500, and standard deviation is 7,000. So if you put this value in Excel, you will get the value of on the x-axis or in terms of salary. So please note that in this function, Microsoft does not use that cumulative values like true or false.